Hey guys, welcome to JakeMakes. On this episode, I'm going to be showing you the simplest method possible to heat treat a knife.
Alright, cooler now. Now, as you know, knife steel comes unhardened. It is soft and easily able to be ground, sanded, and drilled so you can make a knife out of it, but it is too soft to take or hold much of an edge. The steel must be hardened first to make a usable blade. That process of hardening steel is known as heat treating, and that is what we're going to be doing today. Now, this method I'm going to be using today will only work to harden simple high-carbon steels. Steels such as 1095, 1090, 1080, 1085, etc. This will not work to harden any kind of stainless steel or any of the more complicated super steels. Those steels require a much more extensive setup with lots of special equipment and tools which neither me or you own. Today I'm going to be heat treating this knife, which I forged out of a railroad spike. As you can see, the knife is all forged and ground out. The bevels are ground and the edge is ground. All that is left is some finish sanding, which I'm going to save until after heat treat. We are ready to go with this knife. For this simple heat treating method, you won't need much. The things you're going to need are charcoal, some pliers, and some welding gloves would be nice. Basically, something to take your knife in and out of the fire with without getting burned. I'm using welding gloves and a long pair of pliers. You will also need a heat-resistant container to hold your oil. You will need some oil. I'm using regular vegetable oil. You can actually use water. I have in the past, but it's not a very good idea because it's too harsh of a quench and it tends to make the metal crack when you stick it in the quench. It's just a little bit too harsh. Oil is much better. Now you can use several kinds of oil. I'm using plain vegetable oil because it's what I have on hand. You can also use peanut oil or even motor oil. I've seen people use used motor oil they took out of their cars. I don't use that because it stinks, it's messy, and I didn't have any on hand. But there are a few different things you can use.
You are also going to need an air source. Now today I am using an old broken blow dryer. I think the heating element went out and my mom threw it away. But that doesn't really matter because all we're looking for is the air. So whether it's hot air or cold air, it really doesn't matter. It's still putting oxygen on the fire. Now you don't have to use a blow dryer, it's just what I have on hand. I have also used a heat gun. Like I said, hot air or cold air, it doesn't matter. It's just getting oxygen on there. I've seen people use a shop vac with the hoses switched around so that the shop vac is pushing air out instead of pulling it in. I've even seen people use a leaf blower, if you can believe that. I am using this blow dryer. It's, I think, probably one of the simplest things to use. Another thing you're going to need is a magnet, and a way to hold the magnet without and be able to touch the magnet to the metal without getting burned. I'm using an old broken telescoping magnet.
In the backyard, we have this fire pit here. I'm just going to build a little brick box in here, and that's going to be my makeshift forge. This right here is going to be where my air supply comes in. That ought to do. That'll more than do. There we go. A couple pieces of paper here. Forget that. This ought to do it. Alright, now it's been a few minutes. The forge has warmed up to temperature. We are ready to stick the knife in, but before that we are going to preheat the oil. Now to preheat the oil, I'm just going to take a piece of metal, I think this is a piece of rebar, and stick it in the forge and heat it up. Alright, my rebar has reached a hot enough temperature, so I'm just going to go and take that out. And I'm going to dunk it in my oil.
Now all this does is raise the temperature of the oil. I probably got it a bit too hot in this video. You want it to be about 130 degrees Fahrenheit.
Alright, now I am ready to stick the knife in.
As I'm heating it up, I'm watching the color of the steel. After you have heat treated a few knives, you will be able to tell roughly what temperature the steel is based on the color. Until then, you'll just have to trust me. 1500 degrees, what you are aiming for, is a cherry red color which comes just after the metal first starts to glow. This is where the magnet comes in. It is an interesting property of steel that it ceases to draw a magnet when it hits 1345 degrees Fahrenheit. The critical temperature of high carbon steel is around 1475 degrees. As the steel heats up, touch it to the magnet every few seconds. When it stops sticking to the magnet, you know you are close. A few seconds longer, or until the steel has shifted color a notch brighter, and you know you have hit critical temperature, approximately 1475 degrees Fahrenheit. The main difficulty here is getting the whole blade evenly heated to critical temperature. It can be quite a challenge in a small charcoal forge like this. However, it is definitely doable. You just need to keep working at it. You will also need to be careful of overheating the steel. A little bit over and you'll be fine, just let it cool back down a bit. However, you don't want to let it get too far above critical temperature, as you will risk cooking the carbon out of the steel, as well as just melting the steel dead away. Don't underestimate the power of this kind of forge. It will melt your blade if you leave it in for too long. When you are satisfied you have got the blade to critical temperature, you need to move fast, before you lose too much heat. Quickly move the knife out and plunge it into the oil.
And here we go. Wait, a little cooler, now.
I generally agitate it back and forth inside the oil to break up any air bubbles that may have caught in there and make sure that the blade is cooling evenly. In this video, you can see me pulling the knife out of the oil and putting it back in several times. That is known as an interrupted quench. Don't do that. I was just sort of messing around and wanted to see how it would turn out if I quenched it that way. For certain quenchants and certain steels, an interrupted quench can be beneficial, but for this heat treat it isn't necessary, and if anything could make your steel softer. Just plunge the knife into the oil, move it around a bit, and leave it in there until it is cool to touch. After quenching, the steel is extremely hard. So hard that it is about as brittle as glass. If you were to drop it or subject it to any amount of force at this point, it would be liable to shatter or crack. The next step is to heat the blade up again, this time to 400 degrees Fahrenheit. This relieves the stress built up in the steel and softens it down a bit, and you end up with the perfect hardness for a knife blade. There are a number of methods you could use to accomplish this, but the easiest is to put it in the oven at 400 degrees for 2 cycles of 1 hour each, letting the knife cool between cycles. Steel actually changes color as it is heated. A golden brown straw color is 400 degrees, dark brown is 500, deep blue purple is 550, light blue 600 degrees, and so on. You could accomplish this by holding the knife over a fire, hot coals, or even just using a blowtorch. It really doesn't matter. The oven is just the easiest way to do it. At this point, the heat treat is completed and the knife is fully hardened. All that lacks is the finishing up, which is my least favorite part. Quenching has a nasty habit of producing this material known as scale all over the blade. In advanced technical terms, it is commonly known as crud. Now you have to sand all of it off and make the knife look good again, as well as finishing up the grind and everything else left to do, depending on the knife you are making. Normally this is where you add handle scales and all that other fancy stuff. Since this is a railroad spike knife, all I had left to do was finish sanding and final sharpening. Lucky me.